strictly less. And this goes back to, somebody asked me a great question about inclusive versus exclusive. Is that you, Francesca? Inclusive, right? So let's go with strictly exclusive. Strictly less than 26 pounds, okay? Strictly less than 26 pounds. How many?
Yeah, 21 of them.
20% of them? 20? You guys getting that too? So looks like I'm getting 8 25-pounders plus 4 24, that's 12 total.
I'm going with 29%.
Plus, oh, don't include 26. Strictly less than. And that's why I was just saying, Cassie, I would not have the knuckles for that. But we're just going with strictly less than, and the reason I'm going with strictly less than is because of something Tammy said five minutes ago, which I want to come back to. Because what you said is basically the classic definition of percentile rank. And I want to stick with that. So strictly less than, not less than or equal to. Fair? So we'll say 20%. Love it. Let's do another one. How about less than 29 pounds? Strictly less than 29 pounds. Strictly less than 29 pounds. What do you guys say?
I'd say like 40%.
Say it 40%? I'm actually going to count it's okay with you, just because we have believe it or not, we have raw data here. I mean, if you're accepting rounded off to the nearest whole pound, we actually have raw data, which is kind of slick. So we got 13, 7 is 20, 9, 37, 41. 49? Good 49? Lucas, you got 49?
Yeah.
So, ish 50, so right around half. Right around half. So, roughly half, 49%, or roughly half, which would mean, hey, speaking of exam review, we just found the what? Maybe, but we definitely found the what? We had a vote for average, and it might be, no, it might be the average, but we definitely just found the, say it louder, we definitely just found the median, didn't we? 50% below, 50% above, that's the definition of a median. And you end up in the middle. So we just found that, essentially, by finding the 49%, which is roughly 50. Love it. Good. Where's the mode? Where's the mode of this data? What would you call the mode? Cedar, go for it, my friend.
30.
Absolutely, my friend. It's 30 because it's the tallest bar. Remember that. Take the tallest bar, that's your mode. Keep it simple. Mostest, exactly, the most. That's right, Charlie, the mostest. So, let's do one. I need some more C names. How about one last one? 31 pounds. And before you start adding them all up, we're going to revisit a really slick statistical idea that you may or may not remember from your first project.
Just take the smaller part.
Say that again, Athena.
Just take the smaller part.
Take the stuff you don't need away from 100. Yes, Cassie. So if we want to go less than 31, add 31 and more up, which would be what? 11 plus 8 plus 9 plus 1? So that's 20. 20 don't satisfy that, which means 80 do. 80%. I remember hearing this before. Because Max was in the 80th percentile. What that means is we now know how much Max weighs. Max weighs 31 pounds. Because the 80th percentile, this is the definition. This is not like, it doesn't mean anything like holistically. It's a created definition by humans. Since he exceeds 80% of white American 2-year-old boys, that means he's in the 80th percentile for weight. So this is the general definition I want to stick with for percentile. Percentile is a proportion above which you lie. If Max is in the 80th percentile for weight, that means he's heavier than 80% of white 2-year-old American males. If Max is in the 90th percentile for length, that means he's longer than 90% of American white 2-year-old boys. If Max is in the 85th percentile for head girth, that means he's girthier than 85% of white American 2-year-old boys. So that's all that means. Now, I put however on there because there are certain differences depending on who you talk to in how they calculate percentiles. And I think some of this is due to some kind of weird equality reasons. For example, imagine all white 2-year-old American boys put in a line from, let's go with length because it's easier, from tallest to shortest. So you get the shortest white American 2-year-old here, and the tallest one way over there. And that line is going to be pretty long, What percentile is the kid at the end in? He's close to it, but he can't be in the 100th percentile, can he?
99.999.
No, I love that answer, Athena. He can't be in the 100th percentile. Because he can't be taller than himself. He can't be taller than himself. He's taller than everybody else in the line. So let's just pretend, for simplicity in mathematics, there's 1,000 kids in that line, and he's the tallest. That means he's in the 99.99th percentile, 99.9%, 999 over 1,000. So he's in 0.999, which is 99.9 percentile. If there were 100,000 kids in that line, and he's the tallest, he'd be in the 99.999th percentile. With me so far? Fair? It's all making sense. Okay, good, good, good. How about this kid over here? The shortest. Technically, what percentile is he in?
Same thing.
Careful.
That's the smallest.
Careful. So he is the 0th percentile, isn't he? And this is where it gets weird, Michael, because he's not bigger than anybody. By the definition, it's the percentage you're bigger than. If he's the smallest, he's not bigger than anybody, so it's 0 over whatever there is. And I think that's where the different definitions have come from. They say that person needs to have a percentile rank. So they've created new definitions for it. Don't worry about any of them. We're going to explore them in your next take-home exam. I love the question where you actually explore them and you realize there's no difference between them. Essentially, at heart. The reason I like talking about it is how this was used. Because it's interesting anyway. How many of you guys have taken your kids to the pediatrician and you've got these charts? Absolutely. Absolutely. The charts, here, I'll show you the chart that I got to use after Max. Yeah, so here's the actual chart that was used. Now, it's a little bit obnoxious looking until you realize what it's based on. It's based on this. This is the same data you just looked at previously, but instead of making a frequency histogram, I made what's called a cumulative frequency histogram. See if you can buy what's going on here. See if you can buy what's going on here. How many kids were 20 pounds? Do you remember? I think it was 3. I think it was 3 kids.
Yeah, that's
That bar's 3 high. How many kids were 21 pounds? I think it was just 1. But now this bar is 4 high. And it's 4 high because we've made this cumulative. It's not just the kids that are 21 pounds, it's the kids that are 21 pounds or lighter, right? At most 21 pounds. So we add 2 more in at 22, and it's 6, because there were 6 kids that were 22 pounds or lighter. This is an easier thing to pull percentiles off of, because all you gotta do is, they weighed Max, he's 31 pounds. What percentile is he? Well, he's 31 pounds. This bar right here shows the percent that he's above, 80%. So you don't have to go and add up all those individual bars. This is one of those graphs that your book tried to teach you on day 1, and I said, nah, just hang tight, we'll hit it when it makes sense. It makes sense now. Now, very often, the graph is actually made into it's called an ogive, which is kind of a fun name. It's a polygon form. But that's where this comes from. That's why this is shaped like it is. This is the ogive, if you will, for boys from birth to age 3 years. So all they had to do was they put Max, they said 2-year checkup, 24 years old, or 24 months old. They found his weight in pounds, which was 31. Okay, you go up here, you come across 31, right about there. Now, if you look at these lines here, those are the percentiles. So he's between the 75th and the 90th. He's closer to the 75th, so they call it an 80th. It's a good enough ballpark. It's a good enough ballpark. 2 standard deviations would be between the 5th, or excuse me, the 2.5 and 97.5. And we'll get back to that too. You can get a lot of stuff off these charts, a lot of information. Also, what's kind of cool about it is how tightly wrapped together they are at birth. Tightly wrapped together, okay? Very, very small. So pounds, we go from about, what's that, 5 would be here. It's about 5.5 pounds up to about 9.5 pounds. That's a 4-pound difference. If you're off by 3 or 4 ounces in your measurement, the kid, you go from the 20th percentile to the 80th percentile, or not that extreme. But there is a lot of sway there. And it begins to spread out as the kids develop. Which brings me to why I talk about this example. When Max was in his doctor's appointment that day, Jen whatever this was when she got home, 80th percentile for weight. She was asked, what do you feed him? And Jen said, food. And then she realized where the questions were going. And eventually they said, well, he's in the 80th percentile. Jen said, yes, I understand what that means. And they said, hang tight, hold that thought, because that's exactly what I'm going to get at here. Well, we're concerned he's eating too much because of the 80th percentile. So my wife comes back, he's in the 90th percentile for length and the 85th for head girth. Did you measure body composition? Maybe it's all muscle, it's all bone density. And the poor nurse just started backing up, apparently. Because Jen was rapid fire after this stuff. And then she said, well, all we do is anybody over the 50th percentile, we talk about overfeeding and therefore obesity. And anybody under 50th percentile, we talk about malnourishment. So Jen fired back with, so that means everybody gets a lecture about they're not feeding their kid right. Right? Unless you fall right at 50, which nobody's going to, which means you fall right at average. Anybody above 50 gets the lecture about obesity. Below 50 gets the lecture about malnourishment. And then again, backpedaling and backpedaling and backpedaling. But Athena, you hit on the nail on the head. You cannot, look, go ahead, what did you say?
That's got to be your doctor's office, because I've never had that happen. You have to be able to justify, otherwise my kid's going to be a skeleton if I'm...
But what did you say before? When I said he's in the 80th percentile for weight, you said
I don't know, I said compare.
he's in the 90th for length. Why would you just look at one data point in isolation? Why would you do that? You shouldn't do that, right? You shouldn't. It's silly to do that. It's silly to do that because if he is an 80th for weight and say the 50th for length, maybe we talk, maybe. Or we run more tests, do a body composition test.
Yeah.
Maybe he's just very dense. He could have high muscle mass. Muscle weighs a lot more than fat. Although he's mostly jelly at that age. I saw an x-ray. I thought I broke his ankle once on a slide, and he got an x-ray. There was so much jelly in there. There was like no bone. It was pretty terrifying. Tabitha, yeah?
I was thinking if you took these two, like length and weight, and somehow integrated them together so that if you were to cross, you could see if they're in this part, then...
That is such an awesome idea, and what's amazing is I never heard that idea before. 2 hours ago, Julie Keener, amazing math teacher here at COCC, walks in and goes, have you ever seen the ogive for this where they're superimposed? I'm like, no. She's like, when her daughter was really young, they had just that. So basically what Tabitha's saying is put the length and the weight together so that you have a correlation between them. Apparently it exists, I've never seen it.
Like BMI? That seems like it would be better.
BMI would be a third data point. I think so too. I think so too, Cassie. A BMI would be another data point I want to look at. Although BMI, well, it's not that it's accurate. I'm not sure what it's measuring. The problem with BMI is it only looks at height and weight. It doesn't look at, say, body surface area, which is BSA, which is something else to look at. There's all kinds of cool formulas out there, but looking at any one in isolation is a no-no. It's like when I went, I think I told you guys this. I went and got my blood work done. I came back, a positive test result for hyperactive thyroid, or a thyroid burnout. I've got 30 different test results that are saying that I'm perfectly fine, and one saying that my thyroid's off the charts. And the first thing is, let's get you on thyroid medication for life. Okay, time out. Could it be a false positive? Maybe. Could that be an inaccurate test? Why don't we take the test again in 3 months and find out? So in May or something, I will test it again. But that's the thing. If you look at a number in isolation, you kind of lose the forest for the trees, if you will. So very good points. Very good points. You got really upset with that too. I'm sorry. I didn't strike you close to it. You're a nursing student, right?
No.
No, you're not a nursing student. I got some nursing students in here. I got Tammy. I got some nursing students. Got a few, Cassie.
I just had to deal with it. I have a kid that's in the 95th percentile.
And then right. So when you have to deal with it in that way, exactly. I remember a movie back in the 80s called Flatliners. This is also used. Percentiles are also used in academia sometimes. There's a scene in the beginning where the professor walks in and goes, "There will be 2 A's, 5 B's, 9 C's, 5 D's, and 2 F's on this exam coming up." And then the students have to basically fight tooth and nail to get the highest grades, because the highest grade will get an A. The next highest grade will get an A. The next highest grade will get a B. It doesn't matter if everybody gets a 40%. The highest 40% will get an A. And it's kind of a crappy way of dealing with grades on exams. And so I don't do it that way. I don't do it that way. So what I'd like you to do is, I do want to collect some data that I want to analyze for next time, because we're running a little bit short on time. What I want to talk about, let me give you the overriding idea of where we're headed. And I want to collect the data set, and then before we start computing the data set, we'll come back next time and do it. So what we've been looking at with measures of center and spread and variation, I'll use variation. That's what we've been looking at. And I'm not saying this is going away. We will continue to look at this. This is important. It's not that it's not important. It's that some industries, some applications also look at what I like to call measures of relative position. So I like to think of it as absolute position. And the reason for this is simple. When you guys walked in here the first day, I showed you my grading scale. You get between a 90 and 100, you got an A. Everybody in here could get an A if they end up with a 90 to 100 for a grade in the class. That does not exist with relative position. Relative position says, here's a distribution. Where do you fall on that distribution? You will score accordingly. So the problem with relative position for grading is, if the highest grade is 40%, that person gets an A. It doesn't mean that they mastered the material. It means they somehow got a little more points than everybody else, right? The problem with relative position is, if everybody crushes the exam, so suppose you get a 90, the lowest grade on the exam is a 90%. That person fails, right? Lowest grade fails. It's terrible, exactly. Drew's like shaking his head. It's because I don't do it that way. I never do it that way. I grade absolutely. I grade based off an average and a standard deviation and your performance on that. But relative position is used quite a bit. So I'm going to collect the data set that we'll play with next time. On your data sheet that I gave you last time, there's a map. There's a map of the United States. I have a couple extra copies in case you guys weren't here last time. You might need them. Eric, here you go. Kels. Here you go, Eric. You guys in the back, you're good to go. Good to go. All right. So what I want to do real quick is before you guys leave, I want to collect the data set of how many states you've been to. You don't have to have this on the movie. Let me turn this off for now.